Section 4.6 is a summary of curve sketching. So usually with the textbook, I go right in line with their examples, do exactly as they do, and try to follow what they do very, very closely. But on this section in particular, I'm going to kind of break rank from the textbook. I'm going to take the process a little bit slower than they do. They do every single thing that I do, and I do every single thing that they do. So it's all the same, but I kind of separate it into more steps rather than just throwing it all together and having you do it all at once. So what's the idea here? The idea is we need to be able to say everything about any function, everything there is to know about any function that we would need to know, including graphing the function without the help of any technology. And again, that's really important. We are not going to be using technology when we go through this process. So the only reason that we would use technology is to verify our results. So I strongly encourage at the end of every problem, after you've graphed it, that you get on to some graphing utility or even the free apps that I've shown you online to graph the function like Desmos, graph the function and check your answers in something like Desmos or a graphing calculator. But that is only to check your answer, that is never to get your answer. So when you show your work on your test, I need you to show this work, this process, every one of these steps, and then you can get your final answer. A lot of students try skipping steps and going to the answer, which shows me they cheated and used some sort of graphing utility. So make sure you're showing every single step of the process. So what's the idea? We want to know everything there is to know about a function. And in order to do this, we're going to analyze the original function. And when you analyze the original function, you can determine things like domain, x-intercepts, y-intercepts. And if it's a rational function, you can determine any horizontal or vertical asymptotes from what we've done before with infinite limits. Then we're going to analyze the derivative of the function. Remember, the derivative tells you when is it increasing, when is it decreasing, and use the first derivative test to find any relative extrema. Then we're going to find the second derivative and analyze that. Remember, the second derivative gives us concave up, concave down, and inflection points. And then what we're going to do is we're actually going to be able to put all of that information together, and we can actually determine the exact shape of the graph. And this chart is absolutely key for you to understand. So if you remember f prime increasing, that means that it has to be, f prime is positive means your function has to be increasing. F double prime positive means that your function has to be concave up. So it has to be part of a smile. So if you're part of the smile and you're going up, what part of the smile do you have to be? You'd have to be the right half of a smiley. Okay? So we can put, if we know that both my first derivative is positive and second derivative is positive, I have to be the right half of a smiley. Likewise, if my first derivative is negative, I'm decreasing. If my second derivative is positive, yet again I'm concave up, so I'm part of a smiley face. So the question is, which part of a smiley face is decreasing? And that would be the left half of a smiley face. So if your first derivative is negative, second derivative is positive, you have to be the shape of the left half of a smiley face. Let's keep on going. If your first derivative is positive, you know you're increasing. If your second derivative is negative, you know you're concave down, which is the shape of a frown, right? So looking at a frown, which half of the frown is increasing? The left half of the frown is increasing. So if your first derivative is positive, your second derivative is negative, you have to be the shape of the graph has to be the left half of a frown. If your first derivative is negative, you're decreasing. Second derivative is negative, you're concave down, so you're the shape of a frown. So the question is which half of a frown is decreasing? And the answer is the right half of the frown is decreasing. So anytime both your derivative and your second derivative are negative, the shape of your graph has to be the right half of a frown. So the beauty of this is if we know everything about the first derivative, which we'll get from step 2, and everything about the second derivative, which we'll get from step 3, we can actually determine the exact shape of the graph. Not only whether it's going up or down, but does it open up or does it open down? So is it the left or right half of a smiley or a frown? And once we put all of that together, everything from step 1, which is your intercepts, your asymptotes, your intercepts and your asymptotes come from step 1. Everything from step 2, analyzing the derivative, which would be your relative extrema. Anything from step 3, which would be your points of inflection. We're going to plot all those points on the graph, and then we're going to determine what are our shapes on those given intervals, and we'll connect those points using those shapes depending on what it is. So we're going to go through several examples of this. It is a lot of work. Each one of these problems takes anywhere from 5 to 10 minutes long, sometimes even longer if you're not very good at your algebraic skills. So I'm going to try to pick some on the test that aren't too bad, that aren't too undoable, but I still need to see truly this 5-step process for each one of these problems. And again, this is not the exact work that they show in the textbook, but this is the work that I expect to see on the test. So I want to see you break it down. Again, analyze the original function, analyze the derivative, analyze the second derivative, put it all together, and make the graph.